In modern air combat, information is power, and no fighter on Earth gathers, fuses, and weaponizes information like the F-35 Lightning II. This is not just a jet, it is an entire battlefield network in a single airframe. While conventional fighters rely on raw speed and maneuverability, the F-35 operates on a different principle entirely. It sees first, strikes first, and often disappears before the enemy even knows what happened. In an era where warfare is increasingly defined by data, sensors, and electromagnetic dominance, the F-35 represents a fundamental shift in how nations project air power. Today, we're going deep into what makes this aircraft the most advanced fighter jet ever built. The story of the F-35 begins in the 1990s when the United States launched the Joint Strike Fighter program. The goal was ambitious: replace multiple aging aircraft with a single adaptable platform. One design that could excel in air-to-air combat, ground attack, electronic warfare, and reconnaissance. The Pentagon was facing a problem. The Air Force needed a replacement for the F-16, the Navy needed a new carrier-based strike fighter, and the Marines required a vertical takeoff jet to succeed the aging AV-8B Harrier II. Developing three separate aircraft would cost hundreds of billions of dollars. The solution? Build one highly adaptable airframe with three variants. Lockheed Martin's X-35 proved itself in a series of competitive trials against Boeing's X-32, winning the contract in 2001 and evolving into the F-35 we know today. The program created three distinct versions: the F-35A for conventional takeoff and landing, optimized for the Air Force; the F-35B with short takeoff and vertical landing capability for the Marines; and the F-35C, a larger variant with reinforced landing gear and folding wings designed for aircraft carrier operations. Development wasn't without challenges. The program faced cost overruns, technical delays, and intense scrutiny from critics who questioned whether one aircraft could truly fulfill so many roles. But after years of testing, refinement, and operational deployment, the F-35 has proven itself as a transformative weapon system that has redefined what a multi-role fighter can achieve. At the core of the F-35's dominance is stealth. Its radar cross-section is comparable to a metal marble. Every line, angle, and surface is shaped to deflect radar waves. Weapons are stored internally, minimizing detectable edges. The F-35's coating and airframe structure make it extremely difficult for enemy sensors to track, lock, or engage the aircraft. But stealth is more than just shape. The F-35 employs what's known as low-observable technology across multiple spectrums. Its exhaust system is designed to reduce infrared signature, making it harder for heat-seeking missiles to acquire the aircraft. The edges of the airframe are aligned at specific angles to scatter radar energy away from the source. Even the canopy is coated with a thin film of metallic particles that reflect radar while still allowing the pilot to see clearly. Internal weapons bays are critical to maintaining this stealth profile. While carrying missiles and bombs externally increases an aircraft's radar signature dramatically, the F-35 keeps its primary weapons tucked inside the fuselage until the moment of release. This design choice represents a calculated trade-off: slightly reduced weapons capacity in exchange for near invisibility to enemy air defenses. The result is an aircraft that can penetrate heavily defended airspace where fourth-generation fighters would face catastrophic losses. The F-35 doesn't need to outmaneuver surface-to-air missiles. It simply avoids being detected in the first place. Stealth keeps the F-35 hidden. Sensor fusion keeps the pilot aware. The aircraft combines input from radar, infrared cameras, electronic surveillance systems, and satellites, merging them into a single, real-time picture. Instead of managing dozens of data sources, the pilot simply sees the entire battlefield at a glance. This is where the F-35 truly revolutionizes air combat. Traditional fighters require pilots to manually correlate information from multiple sensors, cross-referencing radar contacts with infrared signatures and electronic emissions. It's mentally exhausting and leaves room for human error. The F-35's onboard computer does this work automatically, presenting a unified tactical picture on the pilot's displays and helmet-mounted visor. The APG-81 AESA radar provides unprecedented detection range and resolution. The electro-optical targeting system gives pilots high-definition infrared imagery for target identification and tracking. The distributed aperture system consists of 6 infrared cameras positioned around the aircraft, providing complete spherical awareness. The pilot can literally look through the fuselage of the jet to see threats. But sensor fusion extends beyond the individual aircraft. The F-35's advanced data links allow it to share information seamlessly with other F-35s, surface ships, ground forces, and command centers. A single F-35 detecting an enemy formation can instantly transmit that information to an entire strike package, allowing coordinated attacks from multiple directions. The aircraft essentially becomes a flying intelligence node, gathering data not just for itself, but for every friendly asset in the area. This level of F-35 pilots consistently report feeling like they're playing a video game where they can see all the enemy positions while remaining invisible themselves. It's an overwhelming tactical advantage that no amount of pilot skill in a conventional fighter can overcome. Despite its stealth focus, the F-35 carries a powerful arsenal. For air supremacy missions, it employs AIM-120 AMRAAM and AIM-9X Sidewinder missiles. For precision strike, it can deploy JDAMs, small diameter bombs, and laser-guided munitions, all while remaining undetected. In non-stealth configuration, the F-35 can carry much larger payloads on external hardpoints, effectively doubling its firepower. The internal weapons bay accommodates up to 4 weapons in stealth mode, typically a combination of air-to-air missiles and precision-guided bombs. When stealth is not required, the F-35 can utilize 6 external hardpoints to carry additional missiles, bombs, or fuel tanks, transforming into a weapons truck capable of delivering massive firepower. The F-35A also carries a 25mm GAU-22A cannon for close-in engagements, though its primary philosophy is to engage targets from beyond visual range using its sensor advantage. The aircraft can employ the full spectrum of modern precision weapons, from anti-ship missiles to anti-radiation missiles designed to destroy enemy air defense systems. What makes the F-35 truly multi-role is its ability to seamlessly transition between mission types within a single sortie. It can begin a mission performing defensive counter-air, identifying and destroying enemy fighters. Then it can immediately shift to suppression of enemy air defenses, eliminating surface-to-air missile sites. Finally, it can conduct close air support, providing precision strikes for ground forces, all without returning to base to reconfigure. The F-35 is now operated by the United States, the United Kingdom, Italy, Japan, South Korea, Israel, Australia, and several NATO partners, including Norway, Denmark, the Netherlands, Belgium, and Poland. It has already seen real-world combat, with Israel reporting successful strike missions in highly contested airspace. Israeli Air Force reports indicate Israeli F-35s have conducted strikes deep into hostile territory without being detected, validating the aircraft's stealth capabilities against modern integrated air defense systems. Beyond Israel, the F-35 has been deployed in combat operations by the United States in the Middle East and has participated in numerous exercises demonstrating its ability to dominate fourth and even fourth-plus generation fighters. In simulated combat scenarios, F-35s routinely achieve kill ratios exceeding 20-1 against conventional opponents. The growing international fleet creates a powerful allied network. When NATO F-35s operate together, they form an interconnected sensor grid that provides unprecedented battle space awareness across an entire theater of operations. This coalition interoperability represents a strategic advantage that extends far beyond the capabilities of any single aircraft. The F-35 dominates not because of a single feature, but because of the way its systems work together. Stealth ensures survival, sensor fusion ensures awareness, network warfare ensures superiority, and multi-role flexibility ensures that one aircraft can perform the missions of many. In previous generations, air forces needed dedicated air superiority fighters, strike aircraft, electronic warfare planes, and reconnaissance platforms. The F-35 consolidates these roles, reducing logistical complexity while increasing combat effectiveness. It's more affordable to maintain one type of aircraft than 4 different specialized platforms. The F-35 also represents a paradigm shift in how we think about fighter aircraft.
It's not about dogfighting or raw kinetic performance. It's about information dominance, network-centric warfare, and the ability to operate inside an enemy's decision cycle. By the time an adversary realizes the F-35 is there, the mission is already complete. The F-35 is more than a fighter. It is the future of air combat. Thank you for watching. If you want more deep-dive military documentaries exploring the technology, tactics, and history behind the world's most advanced weapon systems, subscribe and explore the next episodes in this series. The future of warfare is here, and we'll continue breaking down exactly how it works.